Good morning, good afternoon, everyone. Welcome to Cisco and Avi Networks joint webinar on data center agility with turnkey software-defined load balancing and NFV with Cisco CSP and Avi Vantage platform. For the webinar today, you'll be joined by Ashish Shah from Avi Networks and Gunnar Anderson from Cisco, along with Vijay and Neeraj helping out with the demo. We'll have about 10 or 15 minutes of the slides, and we'll then do a live demo, both the CSP demo and the Avi Vantage demo, and then we'll take questions. At any point, if you have any questions, please ask them on the Q&A panel on your BrightTalk screen, and we'll answer them towards the end. All right, let's get started. Welcome, Gunnar, to the joint webinar. If you want to introduce yourself and then take it away.
Yes, that'd be great. Thanks so much for the introduction. This is Gunnar Anderson. I'm the product manager for the CSP 2100. It's an NFV platform from Cisco Systems. I'm really excited to be here. And I also have Vijay with me. He's a technical marketing engineer on the platform. So I'm going to be going through some slides, talk about the platform itself, and then we can answer questions at the end. So just as a quick introduction, we've been working closely with Avi for probably the last 6 months together, especially around a large customer opportunity. They're actually going into production this week, running their load balancer on the CSP 2100. So they have a couple of our hardware units they've been testing and validating in their lab in San Jose for the past several months for this particular customer. And we're also working together on a number of opportunities. So it's working out quite well. So we have Avi running on a cluster of an initial deployment of 12 nodes in the cluster, and that will be in Europe, and then that's expanding to both the U.S. and Asia in the coming weeks into larger clusters. So this has been a great partnership thus far. We have support all up and down the product management level, which is my level, engineering, and even at the TAC level and executive level. So pleased to have this partnership with Avi. So let me jump to the next slide. So let me just take a step back, and these are some of the reasons why we created this platform. I've been with this platform since day one. Started about 2 or 3 years ago. We were talking about it, but the problems that this platform addresses is really giving teams outside the server team speed and agility. Some of these teams, like the network team or security or load balancing team, they may not have access to OpenStack or vCenter server. This platform gives them the ability to spin up virtual network services within minutes. We also are leveraging KVM and Linux, so you don't have the support costs that you would with a proprietary hypervisor. OpenStack definitely has its place in some cases, but in a lot of cases, it's just either it's too complex or there's too much overhead. And what I mean by that is with OpenStack, you need 7 to 9 nodes to get started. These are consisting of management and control nodes. Whereas with the CSP 2100, it's very hyper-converged-like, so you can start with 1 node and then you can scale out from there. Also, the other thing that we've done with this platform is we've leveraged something called ConfD from our Tail-F acquisition 2.5 years ago. So ConfD essentially puts a layer on top of Linux. So by doing this, you're able to manage the platform either through the GUI, which I'll show you later, through a CLI, which is based on IOSX, our syntax, or through a REST API, or even the standardized interface, netconf yang. So at the end of the day, what this gives you is a NFV platform with the the performance of hardware, but with the speed of software. So what exactly is it? Like I said, it is a turnkey platform. We do go to market as an appliance. And I'll show you here the demo later, but we have a full-blown GUI that you can manage the platform. You can use the CLI, or you can use the REST API, and there's consistency across all of these management interfaces. We are leveraging KVM. We do support any of the applications running DPDK, and then we're using Intel NICs, Niantic today, and we're currently qualifying the Fortville NICs. We are also using OVS when needed, or otherwise if performance is needed, we do leverage SRILV and PCIe pass-through. As you can see here, so in this particular example, we would run, and you could have a cluster of these. So we have the Avi controller, and then the Avi service engine could be running both either on the same node or across several nodes. Today we have a fixed platform that we're selling, and then shortly we're moving to modular platforms, and those will be configurable, and you can pick the processor's memory and NICs that are appropriate for your virtual network service. Now let me talk about why people are using the particular platform. The biggest reason is that we're making it super simple to use. Our tagline is insanely simple. Quickly get up and running. Have an out-of-the-box experience, whether it's one node or 10 nodes. And then we do have automation for your DevOps team. We do support the northbound controller as needed in your environment for NSO. And then we also have the ability to cluster these devices just like you would in a hyper-converged environment. And lastly, a lot of the VNFs out there for network services, including Avi Networks, need things like DPDK, PCIe pass-through, and SRILV, and we're offering all three of these things. Okay, with that, I will now turn it back to Avi Networks.
Thanks, Gunnar. Thanks for the introduction. Appreciate that. So we'll spend a little bit on Avi Networks itself. Avi Networks got started about 4 years ago with a mission to provide software-defined application services, load balancing, application monitoring and analytics, application security for the next generation software-defined environments, including private cloud and public clouds. The company itself has a leadership team coming from the Fortune 500 companies, including Cisco, F5, NetScaler, and NetApp, and others. And our product, the software-defined application services product, runs on x86 servers, in this case specifically Cisco CSP. So it's a 100% software product that can run on an NFV platform like Cisco CSP. And as Gunnar mentioned earlier, we have joint customers in financial as well as other technology and other verticals who are running Avi in their mission-critical production environments. So let's step back again and try to understand what is the problem that Avi is solving. If you look at any next-generation data centers and today, you will see that you have hardware load balancers. On one end, you have the compute and application environment, which has moved to the web scale. You have, if you look at Facebook or Microsoft or Google or Amazon data centers, they have x86 servers running applications, and you have scripts and automation that helps you scale out and scale in and deploy applications on demand. However, the load balancers and other network services are still tied to proprietary hardware, which doesn't provide the level of automation that you need, doesn't have the telemetry that you require, has static capacity. You're managing them as appliances versus having a really cloud-like experience. So that was the genesis of Avi Networks' solution. So how did Avi Networks actually solve this problem? Avi Networks has built what we call Application Services Fabric with a centralized control plane and distributed data plane. So applying the SDN principle or the software-defined principles to load balancers and other application services. The centralized control plane, the controller, is your single point of control and management, and the distributed data plane, the service engines as we call them, are deployed on a bare metal server, on a Cisco CSP, for example. They can run as VMs in any other hypervisor environment, including KVM, the way we are running in CSP, or they can run as containers All of these are on-prem or in public clouds such as AWS and Google and Azure. The Avi controller is your single point of orchestration and management, so it manages the lifecycle of the Avi service engines, spinning them up, spinning them down, scaling out, providing high availability, but also doing intelligent placement of VIPs, of virtual services. So you, as an administrator, is talking to the controller for your application configuration, and Avi controller automatically spins the service engines up and places the VIPs on them on individual load balancers intelligently, automatically. This, in addition to doing southbound automation of load balancing fabric, the Avi controller with its REST API also integrates with the orchestration ecosystem, being OpenStack or vCenter or automation tools such as Chef, Puppet, or Ansible, or public cloud environments and container environments. So it's end-to-end automation, both southbound and northbound. And these load balancers, beyond just doing load balancing in SSL and other ADC functionality, also are collecting hundreds of logs and metrics every minute, pushing it up to the Avi controller, which then provides a centralized dashboard, not just for reporting, but also using that analytics information for making automated changes onto the underlying fabric. For example, when the latency goes up or the throughput increases suddenly from the application, it spins up additional load balancers as well as additional application instances on demand. So it's a fully automated, intelligent, elastic fabric. Okay, so for that introduction on Avi, let's move to the best of the both, which is the Avi's elastic software-defined load balancing solution running on turnkey Cisco CSP platform. Right? You get best of both, industry standard hardware running on Intel x86, so it's no proprietary hardware, with the flexibility of Avi software. On the CSP side, it eliminates the network team from managing their the servers, the OS patches, etc. It's a turnkey platform. And with Avi running on top of it, you get the elastic Lego block scaling, right? As you need more capacity, you just keep adding these Lego blocks, right? You don't have to worry about proprietary hardware anymore. As a result, it lowers the overall TCO of the solution while providing the powerful application analytics. Just as an example, let's say you have an application running with a few users, you start with one or two of these CSPs. And as your application workload increases, as your user demand increases, you can just keep adding these Lego blocks, and you have an elastically scaling load balancing fabric with Avi on CSP. All right, so let's see this in action. So now let's move over to demo. Gunnar, back to you. When you're ready, we can start doing the demo.
Okay, great. Thank you. Let me switch to the demo at this time. So I'm going to share my screen here. Okay, can you see my screen, Chandra?
Yes, I think it's good to go, Gunnar. We are ready for the demo.
Okay, great. Okay, great. Thanks. So at this point, this is the dashboard of the screen. I'm not going to go through the full-blown demo today, but I just want to give you a quick overview of the GUI. We also have the CLI, and I said the REST API. So this particular product, the 2.1 release, we just shipped in August 18th. But here I log into the platform. Here I see 4 nodes, and if I drop down here below, I can see the number of cores across this particular cluster. The GUI will actually support up to 10 nodes, and then beyond, you can actually scale higher, using a northbound controller. So here we're showing the amount of cores we're using here, roughly 17%, the memory and the amount of disk space. So, and then I can go in, I can even zero down on which node I want to look at, and it could be across this particular cluster, and then what services are running, on those. So if I select this one here, okay, we don't have any on that one, but let me go to, I think they're all on 3. So if I go here, then it'll show some services here that we have running here. This is in our lab environment. And if I want to spin up the other thing, I'll go to a configuration. So we do support even NFS today in SNMP. So these are the services that are running in this particular cluster. And then if I want to spin up a service, it could be any service. It could be Avi or any service based on KVM. And I'm just going to pick for today's, sometimes the bigger services take some time. For the sake of today's demo, I'm going to pick a simple Ubuntu image. So it's just a sample Ubuntu. And as you can see, this is how you would spin up a service. And then I pick any, then I can, I can pick any particular host that I want to spin this up on within the cluster. I'll just say 4. And then I would pick the image name. So from here, I could pick, the Avi controller, or I could pick for this one, I'm simply going to pick this tiny core, which is a very small image, and it just spins up, within a matter of seconds. And then here I would pick my VNIC configurations. So here I select which ones I want to add. And then here I would go into either PCIe pass-through or SRIOV. For here, I'll just make this simple. I'm going to keep this a simple VirtIO. And then network, I can do either an internal network if I want to keep the traffic inside the box, or if I want the traffic to be linked to a PNIC, then I would pick an external network. And then from here, I can see which particular PNICs that are up. So I'll just pick this first one here. And let me save that. Okay. And then I'll jump to the next thing I would do is jump to the resources. And here, these are the default settings. For Avi Networks, I think they require 12 cores. And about 12 gigs of RAM and about 64 gigs of space, which is we have plenty for. I'll just leave these default settings for here, and then I would just simply, deploy the image. So that's all you have to do if you want to spin up a service on the CSP 2100. There are also some longer in-depth demos on our YouTube site that you can take a look at that will go through kind of the end-to-end bring up of a system. So with that, I will now turn it back to Avi, and then they can go through the demo of their load balancer.
Sounds good. Thanks, Gunnar. So let me take control over the presenter role, and then I will go through the Avi Networks demo. That was very good. So folks on the webinar, what you saw was how easy it is for Cisco CSP to spin up any NFV service, whether it's a server image or an Avi solution. And what this gives you is the ability to have a standard x86-based platform for running your NFV environment, no more proprietary hardware. We'll switch gear now to how Avi does how Avi provides the software-defined elastic load balancing services. Okay, so I'll move over to my demo system, and what you see here is a web-based UI into the Avi controller. What you saw earlier in the slides was Avi provides a centralized Avi controller with a distributed elastic load balancing fabric. So I'm going to log into the Avi UI from this web-based browser, and I'm logging in as Ashish. And what I see is that for me as a user in the demo tenant that I've logged into, it's a fully multi-tenant environment, the set of applications that I'm running, I have about 13 virtual services or 13 VIPs that I've configured in my demo environment. Unlike a traditional load balancing and appliance-centric solution, what you see an application-centric view, where because the Avi controller is automatically managing the life cycle of the underlying infrastructure, you don't have to worry about is my load balancer up or down or what the traffic is. It gives an application-centric view. Now, of course, if you want to see the load balancers, you can see here under the infrastructure tab, there are about 9 different service engines running. But the real reason you're deploying any NFV solution is for your applications. At the end of the day, that's what your top line business is dependent on. You'll also notice that the applications are color-coded by the health score, and the health score itself consists of the application performance, the throughput, the latency, any errors, as well as the resource utilization of the underlying hardware. So for example, when it's running on CSP, whether it's saturating the underlying CPU or memory, in which case it gives you indication that you need to scale out, or any anomalous behavior, sudden spike in latency or a drop in throughput, as well as any security concerns, whether it's a denial of service attack at the application level, or any misconfiguration, or maybe an expiring SSL certificate, etc. So it's a very comprehensive, holistic view on your application health. But beyond that, it also gives you a view on your infrastructure at the application level. So for example, I have this demo application that's deployed on this specific load balancer or service engine that is automatically managed by the controller. It has 3 pools of application service members that it's content switching on, which VLAN these servers are connected to, what the specific backend server IP addresses are, what the health is. For example, one of the application servers is down because the ARP is not getting resolved, so the server is unreachable. So very visual indication on your end-to-end application health, from your virtual service configuration to your load balancer to the backend servers. Now, let's all go into how easy it is to spin up a new virtual service, right? Again, to contrast this experience with what you have in your proprietary load balancer environment, because you're running on a standard CSP x86 platform, it gives us the flexibility to not just elastically scale out and scale in, but also have high performance solution just running with Intel x86. The first thing my wizard asks me is, well, where do you want me to spin up the load balancer? I can spin up in an OpenStack environment, or a vCenter environment, or a CSP environment, or a bare metal environment. Basically, it's a truly multi-cloud solution. I have my traffic running in my vCenter environment, so that's where I'll do the VIP creation. So let's go ahead and go ahead with the VIP configuration. I'm going to give it a name. It's called just a demo VIP. I'm going to configure HTTPS because I do want SSL, and I'm going to configure a certificate, and I want EC certificate, elliptic curve. I'm going to give it a name, or I can give it an IP address for the virtual service, and it automatically picks up the IP address from the DNS that I've configured. So my front-end configuration is done. You can see how easy it is. On the back-end side, when I'm ready to configure the application pool members, instead of typing these manually, I can do auto-discovery. I can talk to the underlying environment. In this case, it's a vCenter environment. So I know my network, my applications are running on VLAN 100. I select that. I get a list of all the VMs that are running in VLAN 100. Again, this applies same to whether it's running on a KVM on a CSP, or in an OpenStack environment, or an AWS environment. It works identically. I know I want to load balance a web application here, so I search for that. I add those servers, and my pool is ready. And I say save, and that's it. My VIP is ready. On the background, what's happening is the Avi controller is spinning up these service engines on demand, putting their vNICs in the right port group, putting the VIP, downloading the VIP configuration on the virtual service, on the service engines, and it's ready to receive traffic. Let's actually run some traffic. So I'll move my dashboard to real time, and I'm going to do a demo, do a HTTP request to the VIP that I just created. There you go. I did ashish.demo, and what you'll see here is that when I go to my log screen, you'll be able to see that the traffic that I just ran has come through. For example, right here, I'm running in my internal network in my lab with this IP and port. I'm on my Mac OS running on a Chrome browser with this SSL configuration at this timestamp. It took me 6 milliseconds to go from my browser to the virtual service that's running, the service engine that's running in my lab environment. That the latency between, so this is equivalent of a WAN latency, if you will, for external applications. The latency between the load balancer to the backend servers, where I'm load balancing, is about a millisecond. The application response time, the time that application took to process and respond, is about 100 milliseconds. And finally, it took 30 milliseconds on the wire because it was a 2.5 or almost 3 megabytes of file. And the URI was a video. It is a web video that we are rendering on the website that you saw here. So what you can see here is that Avi, beyond just providing a faster way to provision, an automated way of provisioning, it provides end-to-end visibility and analytics on the same product. Let's dig into that piece a little bit on the analytics piece. And you should know that, by the way, that's a full-featured ADC. So in terms of the level of advanced policies, for example, HTTP request rewrites, response rewrites, advanced rules, security, SSL. It has all the set of capabilities that your hardware load balancers have, but in a software elastic form factor. Let's look at another application where I have some more traffic running. So I'll move my dashboard to 6 hours, and as you can see here, I can go back in time up to a year. And what you get is an end-to-end timing dashboard. Think of this as a network DVR for your application analytics. And what this gives you is that over the last 6 hours, what are the average latencies on the WAN, on the local network, on the application processing time, and the time on the wire. It gives you a single dashboard to tell you how my application is doing, if it has a problem, where the problem might be. As a network admin, you probably know this feeling very well, that every problem is a network problem, right? The application is slow, or it must be the network, right? So then the finger pointing starts, no, it's not the network, it's a server or it's the application. Well, this tool is your mean time to innocence tool. And what I mean by that is it quickly identifies and zeroes into where the problem might be. For example, if I go back in time here, I see here that there's a spike between 8 a.m. this morning and 9 a.m. In the latency. The green bar is the the network latency. It's reasonable. It's going between 90 and 100 milliseconds. The yellow bar, which is the application latency, is suddenly shot up to 68 milliseconds, which used to be in this range about 30 plus milliseconds. So for that 1 hour, my application latency is suddenly doubled. Well, so it looks like any problem is an application problem in this case. It's not a network problem. So you can go back to your application team and say, what happened between 8 a.m. and 9 a.m. that might require your attention? Now, this was a 10,000-foot view around what's happening at the application level. But you can dig deeper into the specific individual TCP and HTTP transactions. Gone are the days where you need to worry about doing TCP dump on every network interface just to find out where the problem might be. And when you try to reproduce it, it might never happen. Here, Avi logs every TCP and HTTP transactions on this Google-like dashboard that you can search. So for example, you can say, I'm interested in only the traffic that's coming on an iPhone, nothing else. So out of the 40,000 logs, it's filtered down to about 1,400 logs that's coming from an iPhone. And I open one of them up, you can see that this specific transaction came from this IP and port in Nigeria. Naturally, we search for iPhone, so it's running on an iPhone or mobile Safari with this SSL, with this timestamp, with this latency into my data center, this local network latency, application latency, and so on. You can do this type of analytics across various different parameters. If you're an app admin, you can look at which different browsers are using my application, or which different devices are using my application. And so I can optimize the experience for those kind of devices and browsers. If you're a network admin, you can look at what the latency profile is and see if my end users are experience is good or not. In this case, you can see that about 90% of my users have sub 200 millisecond latency. But there is a big spike here down at the 800 plus millisecond mark who have very high latency. So let me filter the logs and then look at a second order analytics. These high latency transactions, are they coming from a specific browser or a device? Doesn't look like. It's pretty evenly spread. Or a specific location. In this case, India. Looks like all the high latency transactions are coming from India. I'll do third order analytics. What component of the latency is the contributing factor? You can actually visually see that. It's a yellow part of the latency, which is the client RTT or the WAN latency, which is about 800 to 900 milliseconds. So you can trace this problem down to the transactions coming from India, and the problem is the WAN link, maybe the ISP has a problem, or the uplink router might be having an issue, or something else. But at least you don't have to worry about finger pointing in a war room and figuring out what's going on. A few clicks and you know exactly what the issue is. Now, this analytics is not just tied to network. It can also give you application level root cause analysis. For example, a very common problem is 404 errors. What? 404 errors are the errors where you have missing pages or missing links. So I can search for 404, filter down to a response code equal to 404. I have about 450 logs in the last 6 hours. Then I can go down here in my pre-configured analytics and click on the URI path. You can find out there are about 4 different URIs in the last 6 hours who have generated 404. But most of them are bogus, or maybe I don't care. But it's really this logo file that's of interest. Then I can find out which of the backend server IP addresses, about 3 or 4 servers that I'm load balancing, only one of them has a problem. All right. So now as a network admin, I'm actually a hero. I call up my app admin and say, it is this server, this file is missing. Can you please fix it? And then the customer will have an excellent experience. You can see the level of analytics and the power that it has to give you real-time troubleshooting capabilities. All right. Towards the end, let's just do a couple more demos, and then we go to Q&A. So the first thing I want to show you is security capabilities. Remember, we are a full-featured ADC, which means we provide SSL offload and give you visibility into what are the different certificate types, what are the different TLS versions that my transactions are coming from, what the security posture is, if my certificate's about to expire. In this case, I don't have a trusted cert, so I'm dinging the health score. Well, there's a DDoS attack that's going on, and if the attack is what type of attack, where it's coming from, and I have the ability to block the attack. Right? Again, very, very powerful capabilities. And then finally, the last piece I want to show you is the elastic scalability. So let me move to real time, and let me move to this screen. You can see here I have 2 service engines. So I've already scaled out into 2 service engines running about 450, 500 Mbps. Now imagine that suddenly, let's say you configured 2 load balancers for a single WIP during your Black Friday or Cyber Monday holiday season, and you're done with the load and you don't need this anymore. Well, automatically, but in this demo, I'm going to do it manually, you can scale back in your load balancing infrastructure so that you don't have to waste your resources, you don't have to over-provision for the whole year. You can just scale out when you need it and scale back in when your workload has gone away. So as you can see here, let's say the workload goes down from 500 Mbps to maybe a couple of 100 Mbps. You can scale in your elastic infrastructure, and it's going to wait until the existing transactions are drained off. And then you'll see that a single load balancer will be able to handle the workload, which is about 200 to 300 Mbps. Imagine doing this on your hardware load balancers. Impossible, right? So now you can see that you have gone down to about 200 to 300 Mbps. And suddenly, let's say you are a retailer and you do a promotion that is you do a sale, and that's suddenly taken off. You don't want to wait for ordering new appliances, right? You have a set of CSPs because they're just standard x86 for your applications, for your NFV in-house. You can go ahead and automatically scale out. Again, automatically based on real-time traffic, or for the demo purpose, I'm going to do it with a single click. And within a few seconds, again, your load balancing capacity for the single WIP just goes out and doubles itself. This level of power, this level of automation is unheard of in an NFV environment. With that, let's go ahead and go back to our slides and wrap up the session, and we'll take some Q&A. All right, so to summarize what we saw here, our customers, Cisco, CSP, and Avi Vantage customers with the joint solution are able to achieve 5x application rollouts, given that you can provision in seconds, you have on-demand application and load balancing scaling, you have full automation with end-to-end REST API, both the Cisco CSP level and Avi level. The faster troubleshooting that comes from the analytics that's built in. And finally, the lower cost of ownership. Our customers, on an average, save 60, 70, 80% on the total cost of ownership. Why? It's software running on standard x86, no proprietary hardware. It's a turnkey solution built on Intel x86. It is no over-provisioning given the elastic scale and the troubleshooting and the flexible licensing. So our joint customers are able to get convenience of an NFV appliance with the flexibility of software. With the Cisco CSP, you as a network team don't have to go to your server team and worry about OS management and patch management. You can scale elastically, lower the cost, and gain powerful insights. With that, let's take some questions. The first question from the audience is, what is the performance when running on CSP? So a two-part question. I'll let Gunnar answer in general the performance on CSP, but I will tell you on the Avi part, we run at line rate. A single core of compute gives, so one CPU core gives upwards of 5 to 6 gig of raw throughput, a gig to gig and a half of SSL throughput, 2 to 3,000 of SSL transactions per second. So it's extremely powerful. And I'm sure, Gunnar, that's true for all types of NFV services running on Cisco CSP.
Yes, yeah, exactly. So I'll take a stab at it, and then VJ can add to anything I missed on that. But yeah, so essentially we have a fixed, so the performance, right, so there's a couple different dimensions. First, I'll just talk about the performance in the CSP and scaling up. So today we're shipping a fixed platform. So it's it's got 2 sockets, 16, 8 cores per socket, so a total of 16. Now we do utilize for our software, we take one particular core, so that leaves you with 15. Now we do, like I said, so they utilize line rate. So we do support SRIOV and PCIe pass-through, so we can bypass OBS along with the hypervisor layer. So we're getting the performance just like you would get on bare metal. So the other thing that we're coming out with here in the next few weeks is essentially modular bombs for 1RU and 2RU platforms. So we actually, just a few weeks ago, they're starting to test it now. So you'll be able to order, if you want, a 2RU platform or 1RU with the latest Broadwell chips from Intel. Those have 22 cores per socket. So you could scale up that way. And then you could run, you'll be able to run either the older Niantic cards from Intel, the 2x10 gig, leveraging SRIOV or PCIe pass-through, and then we're currently qualifying the 4-fill cards, which is the 4x10 gig along with the 2x40 gig. So that's one way you can scale up. The other way, of course, leveraging the Avi technology is based on their architectures, you can scale out, and then the same with the CSP. So you can simply add additional CSPs to your cluster, and then you can scale out both from a throughput and from an SSL transactions per second perspective. So VJ, is there anything else you wanted to add to that?
Yeah, I think, Gunnar, you summarized most of it. Just one point from my side. Like if there is an VNF that requires like high disk activity, then we do have support for solid state drives, so that'll add that dimension to the performance.
Thanks, Vijay and Gunnar. Appreciate your answers. So no, I think that's excellent. So it gives you the flexibility of different hardware flavors with built-in acceleration such as SRIOV built-in, and the Avi architecture which can horizontally scale out on demand. So excellent question. We have a couple more questions here. One says that do the controller and the load balance of the service engines run on the single CSP appliance? And the answer is yes. You can run both controller on a few vCPUs on the CSP and the service engine on the remaining ones. And depending on the scale, if you are looking at a much larger scale, you can also have controllers dedicated on a couple of CSPs as a cluster, and the rest of the CSPs are used as just service engines, or you can mix and match. So again, it's at the end of the day, it's NFV, it is software, and it's compute. So that way you can mix and match dedicated or separate based on your scale. Another question. Are there examples of customers using this joint solution? Yes. So we have joint customers. We have global financial organizations, large service providers, either in a deployment phase and production phase or in the late stage evaluation phase. And I'm sure, given the breadth of Avi's customers across technology, financial services, and service providers, as well as Cisco's presence, we have many more joint customers along the way. And maybe, Gunnar, you can share what type of customers that you're seeing adopting CSP from your angle.
Yeah, exactly. Let me elaborate on that a little bit. So, yeah, we already have customers in production today leveraging both solutions. Yeah, in some cases, just Avi running on the platform. Sometimes there's both Avi along with other Cisco services or third-party services onto the platform. But it really spans, everything from large enterprises to mid-sized companies to service providers. So yeah, I wouldn't say there's any one particular vertical, but it's kind of across the spectrum. And yeah, I guess one reason why I really love this partnership, Cisco does not have a load balancer. We exited that business about 4 years ago, so that this partnership definitely fills a gap in our portfolio.
Exactly, that's an excellent point, and we are actually seeing a lot of customer interest in ACE replacement, Cisco ACE replacement, Gunnar, the business Cisco exited, and this provides customers a very nice transition from a Cisco ACE to a Cisco CSP, which is a Cisco product running with a software load balancer from Avi. And really, the value proposition with the NFV is that they don't have to worry about managing software servers if they get a dedicated NFV platform without getting locked into a proprietary hardware. So it's an excellent win-win situation. There's one more question that just came, which is, can Avi do GSLB across private cloud data centers? Absolutely. Avi can provide GSLB, global server load balancing, across not just private cloud, but also public cloud. So we have customers doing GSLB with a couple of on-premises data centers, bare metal or virtualized, and AWS, as well as Google Cloud. And what Avi gives you is the flexibility of using this as an active-active environment, active DR environment, as well as a cloud bursting environment. And we have a YouTube video on Avi Networks YouTube channel. If you just Google for that, you'll be able to see a live demo in action, how the GSLB works across on-premises and AWS, and basically a true multi-cloud environments. There's one more question, I think, and then let's see if there are more. The last question is, how is this different from a virtual load balancer from Citrix or F5? Well, it's fundamentally different at the architecture level, right? 2 levels. So at the architecture level, Avi is a software-only solution with an SDN architecture, separated control plane and data plane, running on a standard compute x86 environment. If you compare that to hardware load balancers from F5 or Citrix, they're proprietary monolithic appliances. But even if you look at their virtual appliances, it's basically taken the software and put it on a VM. It's not fundamentally different at the architecture level, which means every virtual appliance is running both control plane and data plane. And that's why for the same throughput, what Avi can deliver in 1 core, let's say 1 gig of SSL, an F5 or Citrix appliance takes 4 to 8 CPU cores just to get you 1 gig of SSL. The reason being that same appliance is running both control and data planes. And at the end of the day, you're still managing 10, 15, 100 different virtual appliances. Your operational, your management hasn't changed. You're still managing 100 devices, albeit virtual. With Avi, with the centralized controller, you have one logical load balancer with automated spin up and spin down elastic scale out of your the data plane fabric. And the final difference is the analytics. None of the existing load balancing solutions, hardware or software, gives you the level of visibility, the analytics, and then using that analytics to auto-scale, automatically make policy changes into your environment. That level of analytics, that intelligence, and then combine that with the multi-cloud ability, on-prem, public cloud, true multi-cloud, same consistent experience, same consistent feature set. That's what Avi's value proposition is when you compare to the traditional hardware or their virtual counterparts. Great questions. So with that, thank you very much for joining the webinar. And thank you, Cisco, for the great partnership and joining us, Gunnar and Vijay, for this session. If you have any questions, you can reach out to Avi Networks/contact us for custom demo, or you can reach out to Cisco at cisco.com/go/CSP for any CSP-related information, as well as any request for demo. Thank you very much, and have a great rest of the day.